Hello students, welcome to the IMS Gate Academy. How are you all? So hoping that everything is good and fine. So yet I am again back with one more power pack session of the electrical and electronic measurement, and I hope that all of you had already watched the lecture that I had already taken. Lecture 1, lecture 2, lecture 3 I had already taken. So those who had not watched, please after this session go and watch all those sessions. Definitely will going to get a great advantage from those particular topic. Now this is the lecture number 4. In that I will going to cover again one more important topic, which is the AC bridge. Now here you can expect at least one question from this particular topic. Okay, so the importance of this particular chapter is very high. Definitely you should expect whether you are from EE or IN, all definitely will going to get at least one question from this particular segment. Okay, so guys, one request, please do share the session with your friends so that they also come and join the session in a live manner, so that we're going to have the interactive session, isn't it? Okay, so let us start with the topic, that is the AC bridges. What do you mean by AC bridges? The bridges which is used to measure the inductance, capacitance, quality factor, dissipation factor, and so on and so forth. So the bridges which are used to measure all these things are known as AC bridges. What are the practical example? The practical example of the AC bridges is the wheel balancing. So जहाँ पे हम wheel को balance करते हैं ना, आपने देखा होगा that if the alignment of the wheel is not proper, then we will go to a mechanic and there, like basically a mechanic showroom you can say, and there the person will going to do an alignment of your car, or you can say truck, and so on and so forth. All right, so this is one of the practical example. Okay, and what are the other practical example? In the door sensor, you are also going to have a bridge balancing condition. Okay, so there we are using the DC bridge, or in your wheel balancing we are using the AC bridge. Okay, so yeah, since first we are going to measure, since I had told you that we will going to measure the capacitance, inductance, and so on and so forth. First we will going to measure the inductance, and we'll see which bridges are used to measure the inductance. Definitely this thing is going to be important with respect to the lower grade exam, you can say junior engineer type of exam. Definitely you are going to get the question that which bridge is going to measure the inductance. But once we will going to enter into the particular topic, we'll see how we will going to have the question from the gate perspective. Okay, so these are the bridges which are used to measure the inductance of a coil. So what is a coil? A coil is a combination of the resistor and the inductance. So that is basically your coil. A coil cannot be said as a purely inductive. Coil implies that it is going to have the inductance along, or you can say inductor along with the resistance, is basically a coil. So these are the bridges which are used to measure the inductance of a coil. Okay, so the first bridge is Maxwell inductance capacitance, Maxwell inductance bridge. Second one, Maxwell inductance capacitance bridge. This is very important, this bridge. Okay, next bridge is the Hess bridge. Fourth one, Anderson bridge, and the fifth one is Owens bridge. So I will going to cover with respect to the gate exam. So first we will going to see the Maxwell bridge, then Maxwell inductance bridge, then after that we will move on to the Owens bridge. Okay, because from the Hess bridge and the Anderson bridge, we are having a very rare number of questions, or you can say a zero number of questions from the Hess bridge and a very rare question from the Anderson bridge. So if you going to cover this Maxwell and the Maxwell inductance capacitance, then most of the problem you can easily solve by the help of those concepts. ठीक है? So जो concept हम लोग यहाँ पे discuss करेंगे, same you will going to utilize for the other bridges. So in this segment we will going to cover first, second, and fifth one, because rest two can be self-explanatory, you can say. Okay. So let us start with the first bridge, which is the Maxwell inductance bridge. So this is your symmetric diagram. Let me move this side. So this is your bridge diagram of the Maxwell inductance bridge. So here we will going to find the unknown parameter, means a coil which is unknown. here this is your coil, which is a combination of resistor R1 and inductance L1. Similarly, here R3 and R4, these all are the standard resistor. This should going to be fixed. Means if the bridge is going to be under operation, then these two things is going to be fixed. Now with the help of this R2, ignore this one, small R2, ignore this one. So with the help of R2 and L2, we will going to balance our bridge. Got the point? So what do you mean by balancing the bridge? What do you mean by balancing the bridge? See, this is your detector. This is your detector. When this R1 and L1, by the help of this R2 and L2, are not able to determine, means we are not able to find the exact value, then the bridge is said to be unbalanced. It means that the detector current, which is ID, let me write here, ID current will be non-zero under unbalanced condition. What if the bridge is going to be balanced? Means the bridge is going to be balanced. It implies that we are able to get R1 and L1 value by the help of this R2 and L2. So under this condition, ID current will be 0. Got the point? So let me take the current here as ID. Okay. Now under bridge balancing condition, it implies that your ID current, detector current will be 0. So if the detector current will be 0, can I say that the same amount of current will flow through this R3? If the bridge would have been not balanced, then I1 current is going to be divided into ID and I3. This is ID and this is your I3. And this is your I4. So if the bridge is balanced, means ID is 0, so I1 will be equal to I3 and I2 will be equal to I4. So see the balancing condition. This is Z1, let me take this is Z1, this is Z2, this is Z3 and this is Z4. Okay. So under bridge balancing condition, opposite arm, okay, draw the intersection line passing through the detector like this. Draw the intersection line passing through the detector. Then those line which is cutting the impedance, we will have to take together and in a multiplication manner. So here this is Z1 and this is Z2. So let me write Z1 into Z4, sorry, this is Z4, and which is equal to opposite. Okay. What are the remainings? Remainings are this one, Z2 and Z3. Z1 is R1 plus J omega L1. This is unknown, which we need to be determined, R1 and L1 value. What is Z4, my friend? Z4 is R4. What about Z2? Z2 is R2 plus J omega L2 and Z3 is R3. Okay. So R1 plus J omega L1, this is equal to, see, R2, R3 divide R4 here plus J omega L2 R3 by R4. I hope this is clear to you. Now this two equation is going to be equal if the real part of both sides are equal as well as the imaginary parts on both sides are equal. So from the real part, R1 is equal to R2 R3 by R4, and from imaginary part, if the imaginary part is equal, so L1 will be equal to, क्या होगा? L1 will be equal to L2 times of R3 by R4. So in this manner, by the help of this resistor R2 and L2, we will going to balance the bridge such that we may going to get the R1 value as well as L1 value. Always the variable will be taken as a uncommon element. Uncommon element. This is very important point. So what is uncommon here? Parameter R2 and L2. This is the reason why we always choose the variable which are uncommon. Okay. So let me inbox this. This is very important. Okay, done. Let me add a page, just a second. Okay. So next we will going to determine the quality factor. What is quality factor? The amount of energy stored by the inductor over one cycle divided by amount of energy dissipated over one cycle. Since you are having the coil, Coil is what? Combination of resistor and inductor. So this is R and this is L. So Q is what? Amount of energy absorbed or stored by inductor over one cycle. So let me take omega L by R, because the resistor will dissipate the energy, whereas inductor will store the energy. So this is what? Your quality factor. What will be the quality factor of the purely inductive element? जैसे ये हो गया आपका, this is your inductor. So what is quality factor? Omega L divided by R is what? 0. So this is equal to infinity. What it implies? Please do not say that the quality factor of this coil is infinite, means the energy will going to be stored by the inductor is infinity. No, there is no such concept of the infinity. So what this infinity implies? It implies that whatever energy is supplied by the source, it will be like total energy will be accepted by the inductor. No energy will going to be dissipated, because here you are not going to have any resistor. Okay, so this is a point. So let us find the quality factor or Q of a coil, which is omega L1 by R1. Okay, so what is L1, my friend? It is L2 R3 by R4 whole divided by R2 R3 by R4. R2 R3 by R4. So R3 R4 will be cancelled out, so we'll left with omega L2 by R2. So this is your quality factor. So let me inbox this. Okay. Now next thing. See, as I told you, we are going to have these kinds of method to measure the inductance and the quality factor. Since we are able to measure the inductance and quality factor by the first method, then why we are having the second method? The second method will also going to give the value of L1 and quality factor, which we are already measuring from the method 1 or the bridge 1. Then why we are having the bridge 2? The reason is quality factor is always measured under the resonance. Means what amount of maximum energy that inductor will going to store, that will be calculated under resonance. And for the resonance, we require equal and opposite nature of the element. So what is the equal and opposite nature? Inductor will going to have what? Plus j omega L, whereas capacitance will have the reactive element as minus j 1 by x, such that reactive element will going to be cancelled out. But in our circuit, if you see, there is no capacitance. There is no capacitance. Therefore, the Maxwell inductance bridge is remodified to Maxwell inductance capacitance bridge. I hope this is clear. Okay. So what was the demerit of the bridge 1? We cannot able to determine the the maximum energy stored by the inductor, because that will be calculated under the resonance, and for resonance we require inductor as well as capacitance. Okay. Now come to this Maxwell inductance capacitance bridge. So this is R1 L1, which we need to determine, R2 R3, and this time R4 and C4 are in what? Parallel. Okay. Now using again the bridge balancing condition, Z1 Z2 Z4 Z2 into Z3. This is bridge balancing condition. Under bridge balancing condition we can write. So see, can I write this Z1 as Z2 Z3 Y4? What is Y4? Y4 is admittance, which is equal to 1 by Z4. Now why I am writing this? Because if you are having the parallel component, then admittance can be directly added. Okay, admittance. So see, Z1 is R1 plus J omega L1, Z2 is R2, Z3 is R3, and here what is admittance of R4? It will be 1 by R4. What is admittance of C4? it will be j omega C4. Okay, admittance means reciprocal of the impedance. Okay, all right. So here R1 plus j omega L1, which is equal to R2 R3 by R4 plus j omega R2 R3 C4. So this two equation will is only going to be equal when R1 is equal to R2 R3 R4 and your L1 is equal to R2 R3 C4. So this is your condition under the Maxwell inductance capacitance bridge to calculate the value of R1 and L1. So please do remember this equation is important. Okay, even if you are not able to remember, then we can easily able to derive the things in the exam. Look, there is no rocket science. Just multiply the opposite arm impedances. You will going to have your unknown parameters in terms of known parameters. Done. Now let us calculate the. Okay, just a second. Let us calculate the quality factor Q, which is equal to omega L1 by R1. So what is L1? L1 is R2 R3 C4. R2 R3 C4 divided by R1 is R2 R3 by R4. R2 R3 by R4. Okay. So here R2 R3 will be cancelled out. So we left with omega R4 C4. So this is your quality factor. So let me inbox this. Okay. And one more thing. What will be the variable here? As I told you, variable is always selected the parameter which are uncommon. So here what are uncommons? Uncommon here is R4 and C4. Similarly, in the last bridge, it was R2 and L2. These were uncommon parameters. So this was selected as a variable. Okay, now next thing. Since we are again going to measure the Maxwell inductance capacitance, like by the help of this bridge, we can able to measure inductance as well as quality factor. So the problem that we are having in the bridge 1, we are rectified in the bridge 2. Then why we are having the Hess bridge, Anderson bridge and so on and so forth? What is the disadvantage of the second bridge? The disadvantage of the second bridge is, if you see carefully, that your quality factor, let me write here, Q is proportional to C. Q is proportional to your capacitor. Now, if you want to measure the high quality factor of a coil, then for that particular coil, the capacitor required is will be very, very high, isn't it? Since this quality factor is proportional to C, and such amount of capacitor, like such large capacitor, is not you can say it is not very easy to manufacture, because your bridge is chota and your capacitor is what? Bada for measuring this quality factor. So since there is a constraint over the size of the capacitor, therefore this method is used to measure. This method is suitable to measure medium Q factor coil. Okay, so what do you mean by medium Q factor? If the range of the quality factor is between 1 to 10. So this is your medium range of coil. So what is high range of coil? If the Q is greater than 10, then what bridge is suitable? The bridge which is suitable over here will be this bridge. So here this Q has to be greater than 10 because in this case quality factor is inversely proportional to the capacitance. Got the point? But this need not have to be studied because you will never going to get the question from this His bridge. Okay, so whatever question we are having till date is with respect to the Maxwell inductance capacitance bridge or Maxwell inductance bridge. Okay, all right. And whereas your Anderson bridge, this is used to measure the quality factor less than 1. Means for low Q coil. This is for high Q coil. And this is low Q coil. Got the point? Any doubt? So please do remember, Anderson bridge is used to measure low quality factor of a coil. Hayes bridge is used to measure high quality factor of a coil, and this Maxwell inductance bridge, this is used to measure the Q between 1 to 10. Therefore, it is said to be medium Q coil. Done? Okay. Now let us come to the next bridge, which is the Owens bridge. Again the same thing. From the Owens bridge, we will going to measure our inductance and the quality factor of a coil. Okay, so let us first calculate. Here I will let you know that what will be the advantage of the Owens bridge, or where practically we are using this Owens bridge. Okay, now for that let us calculate our these unknown parameters. Okay, under bridge balancing condition, Z1 into Z4, this is equal to Z2 into Z3. Okay, so here this is this is Z1 is R1 plus J omega L1, Z4 is 1 upon J omega C4, Z2 is R2 plus 1 upon J omega C2, and Z3 is R3. Z3 is R3. Okay. So let us take the LCM over here. What we are going to get here, R1 plus J omega L1. Let me bring this to right hand side. So we'll get J omega C4 into, now take the LCM, R2 J omega R2 C2 plus 1 whole divided by J omega C2 into R3. Okay, please check it whether this is correct or not. Okay, so take the LCM. Now see, this J omega and J omega will be cancelled out, and from here R1 plus J omega L1, this will be equal to R3 C4 C2, C4 by C2. Next, take the imaginary term. This will be equal to J omega R2 C2 into C4 R3 by C2. Okay, please check. This is J omega R2 C2. Next, C4 R3 divided by C2. So C2 will be cancelled out. So we are left with R1 plus J omega L1, and here it will be equal to R3 C4 by C2, and here plus J omega R2 R3 and C4. Now these two equation again will going to be equal if real side on if real part on both sides are equal and imaginary part on both sides are equal simultaneously. Okay, so what is real part from here? R1 will be equal to R3 C4 by C2. R1 will be equal to R3 C4 by C2. Let us check. R3 C4 by C2, and your from imaginary part J omega will be cancelled out. L1 R2 R3 C4. L1, R2, R3, C4. Okay. So yeah, this is your again one more formula to calculate the unknown parameter from the Owens bridge. Okay, again the same thing. What is variable here? Uncommon element. So this C2 and R2. So if you see here, R2 and C2 are the variable. Okay. Now let us calculate the quality factor. Q, just a second. Okay. So quality factor क्या होगा? ओमेगा L1 by R1. If you are having any doubt, please do let me know. Okay. So omega L1 is R2, R3, C4 whole divided by R3, C4 by C2. Let us see what is cancelling out here. R3 will be cancelled out. C4 will be cancelled out. So we are left with omega R2, C2. So this is our quality factor from the Owens bridge. Okay. But as I told you, the practical use of Owens bridge is not to calculate the unknown parameter or the quality factor. Rather, it is used to calculate the relative permeability of the material. Relative permeability of the material. This is very important line. Please note it down somewhere in your copy, that the Owens bridge is used to measure the relative permeability of a material. So what do you mean by relative permeability? If the material is going to attract strongly, please listen me very carefully, if the material is going to attract towards the magnetic field very strongly, then its relative permeability is very, very high, and vice versa. So what are the materials which are attracted towards the magnetic field? Iron and so on and so forth. So the iron is going to have its own permeability, so that I need to be determined. So suppose you are having this as an iron, okay, and this iron is having the relative permeability as mu r. So let me take here, let the material is having relative permeability as mu r. Okay. So here you are having this coil, and in the coil you are going to insert, like inside to that you are going to insert the material. Okay. So where is this coil? This is your coil. So inside this you will going to inside this you will going to insert your material. Okay. Now under this we will going to make the bridge to be balanced. Under this we will going to make the bridge to be balanced. Please understand this particular concept very carefully. Once you going to understand this thing, you can be able to solve any question from this relative permeability. Okay. So now since you have inserted the iron over this, then the inductance L. So since it is L1, so let me write L1. This is equal to mu naught or n square, number of turns, divided by reluctance. What is reluctance? Opposition offered to the flow of magnetic field, which is given by reluctance is equal to L divided by mu naught mu r A, area of the cross section of the, okay. So see, substitute this value here, we will going to get mu naught mu r A n square whole divided by L. So when you insert the iron over here, then your inductor value will be this one. Now under this case, please balance the bridge, okay, by the help of this resistor and capacitor. Since we had already derived one equation L1, which is R2, R3, C4. Sorry. Now balance the bridge. Now balance the bridge when material is inserted. When material is inserted. So let me take for a certain parameters value, your bridge is balanced. Okay. So for that, L1 will be equal to R2, what we had taken, R2, R3, C4, R2, R3 and C4. And this value is basically what? This value is nothing but your mu naught, mu r, A n square by L. Done. So let me take this equation as 1, this equation as 2. Now remove the iron from the coil. When you remove the iron from the coil, then your bridge is again going to be unbalanced. So how we will going to determine L1 value? So once you have removed this iron, then your L1 value, or let me take L1 dash, because since it is changed, so L1 dash will be equal to mu naught A n square divided by L. This time mu r will not come because you have removed the iron. Now under this case, balance the bridge only by the help of resistor. देखो यहाँ पे, this is R2, this is C2. So these are in my hand. So by the help of any of these two parameters, I will going to balance the bridge again. But whatever capacitor, please listen very carefully, whatever capacitor value you have taken for this L1, whatever capacitor value, the resistor value R3 you have chosen, keep those things as fixed. Now by the help of this R2, you will going to balance this particular condition. So let me take the R2 now as R2 dash. Then your L1 will become L1 dash. समझ में आ गया? And since we have unaltered R3 and R3 and C4, it will remain the same. मैं दोबारा repeat कर दे रहा हूँ. R3, R4 को आपको disturb नहीं करना है from the case 1 that we had already chosen. By the help of R2, we will going to balance, or we will going to obtain this value L1 dash. So this is your equation 3, this is your equation 4. Okay, now see the magic. How we are going to calculate this mu r. Okay, from 1, 2, 3 and 4. So divide this 1 and 3, where it is, this 2 and 3, divide 2 and 3 and see what we are going to get. So L1 by, कहाँ गया? हाँ, L1 by L1 dash. So from here it will be equal to, so mu, it will be equal to what? See, it will be equal to mu r only, है कि नहीं? It will be mu r. And here from equation 1 and equation 4, R3, C4 will be cancelled out. R3, C4 will be cancelled out. So here we are left with R2, R2 dash. So my dear friend, your mu r value is determined from R2 and R2 dash. In this way, we will going to measure the relative permeability of any material, But the constraint is, it has to be a material which is attracted towards the magnetic field. Okay, so let us move on to the next thing, that is the measurement of the capacitance. Okay, so here again the same thing, we will going to find the unknown parameter, which is the R1 and C1, and in this we will going to measure the dissipation factor, not the quality factor. Basically the dissipation factor is the reciprocal of the the reciprocal of the quality factor, but for the capacitance, we always measure the dissipation factor, means amount of energy or amount of basically the power or energy dissipated. Okay? So let us see how we are going to calculate. This is your symmetric diagram of the bridges. So the capacitance is measured by the sharing bridge. Okay. Now see how we will going to measure. Under bridge balance condition, detector current will be 0. Then these two impedance का multiplication will be equal to इन दोनों का. ठीक है. Now see, under bridge balancing condition, detector current ID will be 0. So this is your ID. This is your ID. Visible है? Okay, this is your ID. So Z1 under balancing condition, Z1 into Z4, this is equal to Z2 into Z3. So my dear friend, what is Z1? This is the element for which we need to determine R1 and C1. So this is equal to R1 plus 1 upon J omega C1. And what is Z4? Okay, so Z4 here is what? Parallel combination. So let me write in terms of impedance. Okay, in terms of impedance. So it will be Z2, Z3, Y4. So what is Z2? कहाँ गया Z2? Okay, so this is capacitance. So Z2 will be 1 upon J omega C2 into Z3 is R3 and admittance, it will be equal to 1 upon R4 plus J omega C4 plus J omega C4. Let us simplify here. Okay, so from here we can write 1 minus J 1 by J omega C1 and here see R3, multiply this term inside. So what we are going to get? Minus J R3 omega C2 R4. ठीक है, 1 by J is minus J plus, okay, J omega will be cancelled out, so we are left with R3 C4 by C2. Any doubt? Any doubt in this equation? What I have did, I have multiplied this term here by taking 1 upon J as minus J. Done. So we will going to get this equation. Now again comparing real and imaginary part. So see what we are going to get from real part. R1 is equal to R3 C4 by C2 and C1 क्या होगा जल्दी से बताएं. C1, this is equal to C2 times of R4 by R3. Okay, so compare the real and imaginary part, we will going to get this equation. Now again the same thing, which element we should take the variable? Always uncommon element. So what is uncommon here? See, C2 is appearing on both R3. So here R4 and C4 will be taken as an variable. Okay. Now let us calculate the dissipation factor. Okay. Dissipation dF, this is equal to what? Tan del. Del is the dissipation angle. Del is dissipation angle. So this is equal to omega R1 C1. Omega R1 C1. So substitute the value. What we are getting? So R1 C1 multiply C2 will be cancelled out. R3 will be cancelled out. So we are left with omega R4 C4. So omega R4 C4. So this is your dissipation factor of a coil. So the dissipation factor of unknown coil we have calculated in terms of known parameter. So since we are knowing R4, we are knowing C4, we know omega from the supply frequency F, which is omega. So in this manner we can calculate the dissipation factor. Okay, please remember it is a reciprocal of the quality factor, which is equal to amount of energy dissipated over one cycle divided by amount of energy stored over one cycle, and this is nothing but equal to your 10 del. Okay. Now, but this shearing bridge is not only to calculate R1 and C1. It is used to calculate the relative permittivity of the material, which is epsilon r. ठीक है, कभी कभार आपने देखा होगा ना कैपेसिटर के इनसाइड में हम लोग कुछ मटेरियल डालते हैं, जस्ट लाइक योर ग्लास, पेपर एंड सो ऑन सो फोर्थ. So that is nothing but the permittivity of the material. So that I need to be determined. Okay. So let me take the case 1, capacitor with dielectric. So this is your capacitor. This is your capacitor, and inside this I am going to insert the material which is having the relative permittivity at epsilon r. This I need to be determined. क्या इतना समझ में आ गया? Now one more thing, please do remember, here one plate is fixed and another plate is movable. Just say this is your two plates of the capacitor. So this I will going to get it fixed by hinge or by something, and by the help of this spring I make this particular plate to be movable. Done. So inside this I will going to insert this material. Okay, like this. Done. And tilt it by 90 degree, you will get the same image. Done. Okay. So this is the length. This is your length or the distance, basically not the length. This is the distance between the plate. So let me take the this distance as क्या ले ले T, and this distance as D, और opposite कर लेते हैं D and T, because in the book it may have taken like they have taken as D and T. ठीक है? Any doubt? Now see, this is your air, and for the air relative permittivity is what? Epsilon naught. Whereas here the relative permittivity is epsilon r of the material. Now this two will going to have the different capacitance value. See, let me take the capacitance for the air. This is filled with air. This portion is filled with air. So capacitance Ca, this is equal to epsilon naught A by, what is this distance? It is T. Next, this is filled with a material. So here, let me take this capacitance as Cb, which is equal to epsilon naught, epsilon r, A, and what is the distance here? T. A is what? Area of the plate. Area of the plate. So see, this is your plate ka area, which is same for the air as well as for the material. So इसीलिए दोनों में A क्या है? Same है. What is the difference? Difference is in epsilon r and distance between these two. Done. Now please let me know whether these two are connected in series or parallel. These two are plate, then these two are connected in series or parallel. These two are connected in series. See, this is your plate. So from here you will going to connect the source like this. Assume that you are connecting the source over here. So since this voltage is going to be divided into two parts, first will be taken here and the second will be taken here. So since voltage is dividing, so capacitor are connected in series. Capacitor are connected in series. अगर ये ऐसे connected रहता, suppose in place of this, like in place of this, you could have inserted this material in this manner. Then this two capacitance here, the first one is Ca and this portion is CB. Then in this portion, your voltage is what? Parallel to both the capacitance, na? So these two are connected in parallel in this manner. But here these two are connected in series. ठीक है? So I hope इस समझ में आ गया होगा कि कैसे आइडेंटिफाई करेंगे सीरीज एंड पैरेलल. Okay. So see, what is the equivalent capacitance? C1. Let me take C1, this value, equivalent capacitance. So this is equal to CA into CB divided by CA plus CB. Do not write CA plus CB by seeing this in series, because in series capacitance is behave as a parallel of the as that of the resistor. ठीक है, तो जो रजिस्टर का जो फॉर्मूला होता है ना पैरेलल में, वही इक्वल होता है कैपेसिटर का फॉर्मूला इन सीरीज में. ठीक है, नाउ लेट अस सब्स्टिट्यूट दिस वैल्यू. क्या होगा बताओ? एप्सिलॉन नॉट ए बाई टी इंटू एप्सिलॉन नॉट एप्सिलॉन आर ए बाई डी होल डिवाइडेड बाई एप्सिलॉन नॉट ए बाई टी प्लस एप्सिलॉन नॉट एप्सिलॉन आर ए बाई डी. So let us take the LCM over here. So क्या मिलेगा यहां से? This implies C1 will be equal to, this implies C1 is equal to epsilon naught epsilon A का होल स्क्वायर, epsilon naught epsilon A epsilon naught epsilon R, or let me write A together. एप्सिलॉन नॉट A का होल स्क्वायर है कि नहीं? एप्सिलॉन नॉट A का होल स्क्वायर, देन एप्सिलॉन R इंटू 1 अपॉन TD. ये समझ में आया क्या? क्या लिखा? डन. नाउ इन द डिनोमिनेटर एप्सिलॉन A कैन बी टेकन एज अ कॉमन, एप्सिलॉन नॉट A. सो वी आर लेफ्ट विथ 1 upon T plus epsilon R D. So let us see, something is cancelling out over here. Epsilon naught A and epsilon naught A is cancelled out, so we are left with epsilon naught A epsilon R, epsilon naught epsilon R A upon TD होल डिवाइडेड बाय, चलो बताओ क्या आ रहा है? D प्लस T एप्सिलॉन R डिवाइडेड बाय TD. So here TD will be cancelled out, so we are left with epsilon naught epsilon R A upon D plus T epsilon R. So let me take this as equation 1. Okay, so here again we need to determine epsilon R, because here epsilon R are unknown and all the other parameters are known to me. Epsilon naught 8.85 into 10 to the power minus 12 farad per meter. Epsilon R is unknown. A is area of the plate, that we know. D, distance here, that I already know, and this T that I already know. So I know all the things except this epsilon R. Now my dear friend, here this is your capacitance. Now let us balance this particular capacitance by the help of the known parameter. So let us take C1. This is your that value that we have got with the help of C2, R4 and R3. So just a second. Let me have a space, just a second. So let bridge is balanced. By the help of R3 C4 और क्या था? R3 C2 and R4. R3 C2 and R4. Okay, so this is equal to C1 is equal to C2 times of C1 is equal to C2 times of R4 by R3. R4 by R3. This is visible? This is visible? Okay. So this value of capacitance and this value of capacitance both are same. So let me take this as equation 1. Okay. So by the help of this C2, R4 and R3, by the help of this C2, R4 and R3, I have balanced the bridge. Now let us remove the material. Let us remove the material. Then definitely once you will going to remove this material, epsilon R will going to be eliminated. So the bridge is going to be again unbalanced. The bridge is again going to be unbalanced. So this time do not change any parameter to get the changed value of C1. So how we are going to make the bridge balance? Remember I told you movable plate and the fixed plate. So by the help of movable plate, I will going to balance the bridge, and at the same time I will not going to disturb this C2, R4 and R3. समझ में आया मैंने क्या बोला? अब आप मटेरियल को हटा दो तो ब्रिज क्या हो जाएगा? इट विल बिकम अनबैलेंस. Then how we will going to make the balance condition? By changing the plate, not by any of this element. By changing the plate. So earlier it was here. So what was the distance? D plus T, है ना? D plus T. Now let us say you are moving this plate by certain distance, let us say x. By certain distance x. Then what will be the distance between the plate? It will be D plus T. जो पहले था. And now since you have reduced the distance between the plate, it will be D plus T minus x. Now these all are filled with the air. Now let us say for this value of x, your bridge is balanced, which is having the same value as that of C1. ठीक है? तो क्या होगा in this case C1? This will be equal to epsilon naught A. Please do not write epsilon R. Okay. Epsilon naught A upon what is the distance? D plus T minus x. So these are the two plates and this will be your capacitance value. Now since these two are equal, sorry, let me write this as 2 and this is 3. Now since equation 2 and 3 are same, so I can write कहाँ गया? हाँ, epsilon naught epsilon r a, epsilon naught epsilon r a whole divided by d plus t epsilon r, d plus t epsilon r, d plus t epsilon r. This is equal to epsilon naught a d plus t minus x. So epsilon naught a will be cancelled out. So we are left with epsilon r d plus t epsilon r, which is equal to 1 upon d plus t minus x. Let us simplify this. Cross multiply. We'll get epsilon r d plus epsilon r t minus epsilon r x. This is equal to d plus t epsilon r. D plus t epsilon r. Let us see something is cancelling out over here. This will be cancelled out. So we are left with, let me write here. So we are left with epsilon r d minus epsilon r x which is equal to d. So here epsilon r will be equal to d upon d minus x. So since I know all the quantities over here, I know D value, I know X value by how much distance I have shifted the plate, and by taking the ratios, I will going to get the epsilon r. So in this manner, I can be able to find the relative permittivity of the any material. ठीक है, एक बार चेक कर लो यहाँ पे, is everything correct here? So yeah, this is this value. Okay, so epsilon naught a का whole square epsilon r a upon td. Take the LCM, we'll get this one. Okay, this one. Next, we'll get this one, the bridge balancing. Now move the plate by distance x and equate those two. We'll get this value. Done. So please remember what is d in our case and what is x. So d is the distance between the or you can say the length of the material, and what is x? X is by how much distance we have moved the plate, and take the ratios. So yeah, this is all about the AC bridges. Now let us discuss, or let us revise the concept by the help of our gate problems. So this was a gate problem. In the bridge circuit shown, the capacitors are loss free. At balance, the value of capacitance C1 in microfarad. So this is your capacitance C1 that I need to be calculate. Okay. Now since it is given that bridge is balanced, so opposite arm का impedance, remember opposite arm का impedance is equal to remaining. ठीक है, कोई doubt? So let me take this as let me take this value as Z1, this as Z2, this as Z3, and this as Z4. Okay. So under bridge balancing condition, Z1, Z4 is equal to Z2, Z3. What is Z1? Z1 is 1 upon j omega C1. Z4 is 105 kilo ohm. Z2 35 kilo ohm. Z3 is 1 upon j omega C3. Okay. So your j omega will be cancelled out. So C1 from here, what is C1? 105k divided by 35k into C3 is 0.1 microfarad. I hope this is clear to you. So 3 times of 0.1, which is 0.3 microfarad, which is the correct answer for this question. Okay, please do not write C1 into R4, C3 into R2. This will going to give you the wrong answer. Here always remember, we will have to balance the impedance, not the elements. ठीक है, element को नहीं करना है, हमें equate करना है impedance को. Okay. Next question. In the Maxwell, when bridge shown, the detector D reads 0. It means that the bridge is balanced. When C1 equal to 100 nanofarad and R1 equal to 100 kilo ohm, the Q factor of the coil is. The Q factor of the coil is. जल्दी बताओ क्या होगा? First we need to determine the LX and RX in terms of known parameter. So now under bridge balancing condition, opposite arm, always draw the line passing through the detector. Okay, and take the multiplication of those two elements. So here R2 into R4, this is equal to, R2 into R4, this is equal to Rx plus j omega Lx into, let me take this as Z1. है कि नहीं? Z2, Z3, Zx and Z1. Okay. Why I have written Z1? Because I will going to take this to the right hand side. so that it will become admittance, and we know that in parallel we can add the admittance. So here Rx plus j omega Lx, this is equal to R2 R4 Y1. Y1 is 1 upon Z1. So R2 R4. Y1 is what? 1 upon R1 plus j omega C1. So here R2 R4 by R1 plus j omega R2 R4 C1. Now equate left hand side and right hand side. We'll get Rx value as R2 R4 C1 and Lx value as R2 R4 C1. Now some may going to think that सर हमें R1 and L1 को तो यहाँ पे रखना चाहिए था और या Rx and Lx को. No, we can place any element in any branch. I can place this here, this here, this here and this here. I can place anywhere. The thing is, we will have to make the bridge to be balanced. So do not get confused with the notation R1, C1, R2 and R4 by thinking that sir, the unknown parameter we have taken R1 and C1, but here those are known. We can take any notation, we can give any name to the unknown parameter. Only matter is what? Only the matter is what? The bridge balancing condition. Okay, just apply the bridge balancing condition and determine the parameters in terms of known parameters. Okay. Now, but we need to calculate the Q factor of the coil. So what is Q factor of the coil? Which is equal to omega Lx divided by Rx. So omega Lx is what? R2 R4 C1. R2 R4 C1. Anybody has got the answer? Anybody has got the answer? And what about Rx? R2 R4 C1. R2 R4, sorry, R2 R4. Okay, this is R1, not C1. This is R1, okay. So R2 R4 by R1. So R2 R4 will be cancelled out. So we are left with omega R1 C1. Omega R1 C1. So what is omega? See, this is Vm cos omega t. So from here we are going to get the omega value, which is 1000. R1 100 kilo ohm, यानी 100 into 10 to the power 3 kilo. C1 is 100 nanofarad. So 100 nano means 10 to the power minus 9. Nano कार मत समझ लेना ना. So this is nano. Okay. So see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is equal to 10 to the power 10 into 10 to the power minus 9. So this is equal to 10. So the correct answer for this question is 10. Done? Any doubt? Any doubt till this point? Now come to the last question, which is this one. Okay. So this is our question. This I have taken just for my reference. See, for the given balanced bridge, determine the magnitude of the supply current. So this is your supply voltage. This is the supply current for which I need to determine the current value. And this is your bridge. Okay. So since the bridge is balanced, here I need to determine the I value. How I will going to do? How I will going to do? Here I will going to take the help of substitution method from the network. So basically this question is a combination. This question is a combination of your measurement as well as network theory. So what I will do, I will going to substitute substitute 2 volt as equal to, let me write I1 into Z1. Okay, I1 is the current which is flowing here and Z1 is what? The impedance. Together these two will going to give you the 2 volt. So here I have substituted this 2 volt in terms of I1 and Z1. So my dear friends, since the bridge is balanced, so here I have taken I1. So since the bridge is balanced, so no current will enter here. So the same current will flow here, I1. So let me take this current as I2. So the same current will flow here. This is I2. So can I say this I will be equal to I1 plus I2, है ना? यही तो कैलकुलेट करना है, I1 एंड I2. जल्दी से बताओ कैसे करेंगे? जल्दी से बताओ. See, when you do so, we can replace, this is what, just a second. This is 1 kilo ohm. Let me draw the diagram. This is Z1 we had taken. This is 4 kilo ohm. And this is your 2 kilo ohm. This is 2 kilo ohm. And this is your V0. And here we have connected the source. Okay, so this was your Vs. This was your Vs. Now, since the bridge is balanced, so opposite impedance Z1 into 4, है कि नहीं? Z1 into 4 kilo ohm is equal to 2 kilo ohm into 1 kilo ohm. 2 kilo ohm into 2 kilo ohm into 1 kilo ohm. 2 kilo ohm into 1 kilo ohm. जल्दी से बताओ Z1 कितना आ रहा है? So Z1 will be equal to 2 by 4, which is 0.5 kilo ohm, which is 0.5 kilo ohm. कितना होगा? 0.5 kilo ohm. Now since we have got the value of 0.5 kilo ohm, and I know that the current here and impedance here will give you 2 volt. So my dear friend, जरा ध्यान से देखना, this question is very very conceptual and at the same time easy as well. ठीक है? See, since this 2 volt is equal to I1, which was the current here I1, and here the current we had taken as I2, है ना? जरा चेक करने दो. Okay. So I1 into Z1. So since I1 is unknown, I don't know about this I1, but Z1 is what? 0.5 kilo ohm. So from here I1 value will be what? 2 divided by 0.5, 2 divided by 0.5 milliampere. Kilo will go to milli, or it will become milli. So this is equal to 4 milliampere. It will become 4 milliampere. Now if you see carefully, the same current is flowing here, I1. So that is 4 milliampere, and here you are having 2 kilo ohm. Then what is the voltage drop here, my friend? Voltage drop here. So voltage drop here will be plus minus 4 milliampere into 2, which is equal to 8 volt. Here it is 8 volt. और यहाँ पे कितना था? It was plus minus 2 volt. So the total voltage here is what? Plus 2 volt plus 8 volt. So total voltage is 10 volt. So since this voltage is in parallel to this element, है कि नहीं? यहाँ से लेकर यहाँ तक, these two are in parallel. So we know that in parallel the voltages are same. So this 10 volt is equal to 10 volt here as well. So I can easily determine I2. Why? Because the I2 current is same on this branch. So when you apply the KVL here, we'll get 10 volt as equal to I2 current into what is the resistance here? Equivalent resistance 5 kilo ohm. So from this I2 value will be equal to 2 milliampere. I1 was 4 milliampere. Quit out. यहाँ पे now I need to calculate the supply current I, which was equal to I1 plus I2. So add those two, 4 plus 2, Okay, 4 plus 2 will give you 6 milliampere. 6 milliampere. Got the point? So there is one more method, just a second, there is one more method which is known as method 2. So let me draw the diagram first, just a second. This was 142, 1 kilo ohm, 4 kilo ohm. This was the voltage 2 volt. This is 2 kilo ohm. Just a second. Yeah. This is Vs and this is V naught. And the bridge is balanced. It is given in the question. So ID is 0. So my dear friend, since ID is 0, what will be the voltage drop? Let me take a point here. This point is A, this point is B, this point is C, and this point is D. So what is the potential difference between B and D? It will be 0. VBD is 0 under balancing condition, under balanced condition, always. Because since the bridge is balanced, so no current will flow here. If no current will flow here, voltage drop will be 0, isn't it? ID into RD. RD is the resistance of the detector. Since ID is 0, so voltage drop will be 0. Now apply the KVL in this loop. Just a second. Which loop? I am talking about this loop. Okay, I am talking about this loop. Apply the KVL in this loop. Let us see what we are getting. So here let us take the current as I2 and here the current as I1. So apply the KVL, we'll get 2 volt plus VBD minus, so here I have taken plus and here I have taken minus. So and minus, since current is from up to down and I am moving upward, so I will take the negative sign. So it will be equal to I2 into 1 kilo ohm. So since VBD is 0, VBD is 0 under balancing. So from here I2 will be equal to 2 milliampere. Okay. Now see, the 2 milliampere is flowing in this 4 kilo ohm resistor. So what is voltage drop, my friend? What is voltage drop here? So the voltage drop here will be plus, so plus minus. So 2 milliampere 4 kilo ohm, it will be 8 volt. है कि नहीं? Because the same current will flow here because the bridge is balanced. Okay. Now applying the KVL again in this loop. Apply KVL in this loop. So what we are going to get? See, I am moving in this direction. So what we are going to get? 2 kilo ohm into what is the current? I1. Done. Next, in this direction we'll have to move. Current is flowing in this direction and I am moving opposite to that. So minus, it will be 8 volt. And in this direction minus VBD equal to 0. Because when I will move, this negative point will come first. So इसलिए मैंने minus लिखा है. और ये minus क्यों आया? Because here the current direction is from up to down and I am moving down to up. So opposite. इसलिए negative यहाँ पे. So 0. Since the bridge is balanced, so from here I will get I1 value as 4 milliampere. So what is the total current supplied by the source? It was IS, na? or I simply, I, this is equal to I1 plus I2. I is equal to I1 plus I2. I2 is 2 milliampere. I1 is 4 milliampere. So total 6 milliampere, which is the correct answer for the same, which is the correct answer for this question, which we have got the same value. So either you use method 1, this is method 1, or you use method 2. From both you will going to get the same result. Okay. So with this we had completed the one more important topic from the measurement, which is the AC bridges. Do you guys having any doubt in this particular topic? Any doubt? Okay. So whenever you are going to have any doubt from this topic, you can post in the chat box definitely, or you can say the comment box. Definitely I will going to see the doubts and I'll try to rectify as quickly as possible. Okay, so guys, if you have liked the session, please hit the like button as well, and also please share the session with your friend. It keeps on motivating me, okay, and not me, to all of my team. And also please do not forget to subscribe our YouTube channel. It is very important because we are coming up with we will be coming up with a new initiative in the upcoming months, and do not forget to press the bell icon, which is very important. I want you to be the first one to get notified for all of our sessions. And you know that we are currently having the PYQ sessions, previous year questions. So those who have not watched those sessions, please do watch this session which had already held. And from the next week, I will going to start the PYQ of the electrical machine, which are common for both EE and IN. Okay, so guys, if you want to join the Telegram group of the IMS Academy, so the link you will going to find in the description box. Please check it and join our YouTube channel. Our Telegram channel. Definitely you will going to experience a great thing. Okay, so we have a good number of students in over the Telegram. So once you will going to join those, you will going to find the PDF of this particular session on the Telegram group. Okay. So guys, let me end the session and we'll meet on tomorrow with the next topic, which is the frequency and the phase measurement from the CRO, which is again the important topic. So bye bye and take a very good care of your health.